All right, welcome to section 2 of unit 8. We're going to start with some conventions here as far as the way we talk about stuff. We're going to be using angles in the coordinate plane. And so in order for that to happen, we need to make sure we all are talking the same language, all using the same terms, because you can put an angle anywhere and we need to be able to make sure that we're all talking about the same thing. So when we talk about angles, we're going to talk about standard position, which standard position means that, oops, sorry, let's get that back up there. Standard position means that we're going to measure from the positive x-axis. The positive x-axis is our initial side. We're going to go in the counterclockwise direction. And wherever we end, that's the terminal side. That measurement is our standard angle. Now, those would be positive. You can go negative angles. Those go clockwise. So they go the other direction. So every angle, if I'm measuring it here, I can go positive and get there, or I can go negative and get to the same place. So we can have equivalent angles as well that are written in different ways. And just a little bit, we'll talk about the fact that we can also go all the way around a circle and end up there with a little bit of extra distance, and that is still the same terminating side with equivalent angles. So again, we're going to talk about the initial side being the positive x-axis, terminal side where our angle ends. Positive angles go counterclockwise always. Negative angles go clockwise. So just a quick reminder, we have our 4 quadrants on the coordinate plane. We have quadrant 1 here, where everything's positive. Quadrant 2, where the x is negative, y is positive. Quadrant 3, where both of them are negative. And quadrant 4, where x is positive, but y is negative. We're going to be using all of those in our description of where angles are. So now we're going to try to talk about reference angles oftentimes, which is a positive acute angle from the x-axis and the terminal side. So acute meaning it's always between 0 and 90 degrees. Okay, it's got to be between 0 and 90. It's got to be positive. If those are not true, it's not your reference angle. So typically, there's a couple of ways that you can find that reference angle. You can use an equation and say, okay, if this is my angle, I'm in quadrant 2, then my reference angle is how far I have to go to get to the x-axis. And if I'm using degrees, that's this right here, 180 degrees minus the original angle degree. So let's say if this is 120 degrees, 120 takes me here. I need to go another 60 degrees to get to 180, the x-axis, right? This is 0. This is 180. If I go all the way around the circle, this is 360. So we'll talk about that as well. But for now, you can use this equation, or you can just ask yourself, how far do I have to go to get to 180, that negative x-axis right there? If I'm in quadrant 3, then I've gone past 180 degrees, 180 to here. I'm going to take my angle and subtract 180 from it to go backwards and see how far past the 180 degree measure did I go. And again, whatever I find there, that little acute angle between 0 and 90 degrees is going to be my reference angle. And the last one, if I'm in quadrant 4, it's how much farther do I have to go to get to 360? So I've gone almost all the way around the circle. What's left over? And so you can do 360 minus the degrees of your angle. If I'm in quadrant 1, my angle is my reference angle, so long as it's between 0 and 90. Now, unfortunately, both on the notes and in the homework, they don't give us a ton of room to work. So know that if you're doing extra work, you may want to do it on a separate piece of paper. The instructions here, though, for our examples, sketch each of the following angles in standard position, identify the quadrant in which the terminating ray resides. So I'm going to list, I've got the angle itself, I have the reference angle, and then the quadrant where that ends up. So here we go, let's try it. So starting here, 80 degrees. 80 degrees. And again, if you need to, label this 0, 90, 180, 270, and if I go all the way around, 360. So 80 degrees is going to be right here. That's in quadrant 1. And just to note, quadrants are always written in Roman numerals. You have to put it in Roman numerals. That is the convention. That's the way it's going to be in every textbook, every question on a test, every standardized test, everything like that. Always Roman numerals. So we're in quadrant 1, and 80 degrees is already between 0 and 90. So my reference angle is 80 degrees. The next one, 250. Okay, let's see here. 0, 90, 180, 270. Oh, I went too far. 250 is going to be right here. Almost to 270, not quite all the way there. I need to draw in the standard position. I forgot to do that on the last one, right here. That is how I got there. That's my 250 degrees. So then my quadrant, 1, 2, 3, it's in quadrant 3. And the reference angle here, how far is it to go back to 180? So if I'm at 250 here, 250 minus 180 is going to get me 70 degrees. 70 degrees to go back, that's my reference angle. That's the positive angle between 0 and 90. So again, do not go to the y-axis. Reference angles are always to the x-axis. We don't want this one right here. That's to the y-axis. You're going to see that 250 and 270. You're going to want to say it's 20 degrees. Don't do it. Go back to the x-axis. There are ways to make what we're going to do later on work going to the y-axis, but you have to memorize twice as many rules, and you have to decide which one you're going to use every time. Don't do it. Always go back to the x-axis. So the next one, 320. Let's make this a little bit smaller. We're going 0, 90, 180, 270, 360. All right, we've gone almost all the way around the circle. We're at 340. Again, draw in your angle. You need to draw that arrow in. Then we need to figure out how to get to the x-axis. Well, that means I need to go just a little farther. I need to go right there. That distance between the 320 that I'm at now and the 360 is my reference angle. So I'm in quadrant 4, IV, or again, always Roman numerals. My reference angle is going to be 360 minus 320, or 40 degrees. So again, you're showing the actual arc. And so that actual arc is the red part that I wrote here. The blue part is not, oops. See if I can make that undo again. There we go. We'll extend that just a little bit. So this distance to right there, this arc is the standard position angle of 320. And then that little bit left over there is my reference angle. How much farther do I have to go to get to the x-axis? Next one, 135. So, well, that's between 90 and 180. So 135 is right in here. Oops, it's actually going to be kind of right in the middle. And so my arc right there, there's the 135 degrees. My reference angle is this little bit right here. Again, I don't actually need to mark that, but that's what I'm finding. So I'm going to say I'm in quadrant 2. And again, if you're needing to, use these formulas that we had up here. These guys right here, not the radian ones. We'll get to those later. But for now, the degrees ones. So here, I'm doing 180 minus 135. That gets me a reference angle of 45 degrees. Again, always positive, always between 0 and 90. Now, that's enough of the super easy stuff. Let's go with some negatives. So negative 100 degrees, that means I'm going backwards. If I'm going backwards, let's label everything backwards. 0, negative 90, negative 180, negative 270, oops, 270. So negative 100 would be right here, just a little bit past negative 90. So there is my arrow showing how I would get to negative 100. My reference angle is how far I need to go to get to the x-axis, right there. That distance from negative 100 to negative 180 is 80 degrees. The reference angle is always positive. So 80 degrees, and I'm in quadrant 1, 2, 3. The quadrants don't change when you're talking about negatives and positive. This down here is still quadrant 3. For section 6, or question 6, same idea. Go backwards here. Let's use a different color. So here I'm going -90, -180, -210. Oops, nope, that's what we're looking for, -270. Sorry about that, everybody, -270. So 210 would be right here. There's my negative direction. And I have both my quadrant, quadrant 2, and my reference angle. If that E will show up. Reference angle of the distance between -180 and -210, which is +30. Now, a quick side note, if you don't like dealing with these negatives, you could add 360 to this. Say, okay, well, -210, if I go all the way around the circle, add 360. 360, -210 plus 360 would be 150. 150, 150 degrees would be this angle right here. That ends in the same exact place as this one. It's going to have the same quadrant and the same reference angle. And again, if we work this out, this would be 90, this would be 180. And so we'd said that this angle, -210 plus 360, is +150. The distance between 150 and 180 is the same 30 degrees. We'll use that fact later on to rewrite these angles when we need them to be positive. That term is going to be called a coterminal angle. An angle that ends in the same spot as another one is coterminal. They end in the same spot, the same terminal side. All right, let's keep going though. -70, it's right here, right? Not quite to -90. There's my angle. Now I'm in quadrant 4. Again, always Roman numerals. And my reference angle is going to be almost to -90, right? So, but I don't want to measure this distance. I want to go all the way back this way. So I'm just going to take it. I went -70 this way. I'm going to go back +70 this way. My reference angle is 70 degrees, the angle that I already had, but positive. Do not actually use this little 20-degree one right there because that goes to the y-axis, not to the x-axis. And number 8, 295. Well, we've got -180, -270. We went past that. We are going around in the negative direction. We blew past -270 and got all the way to -295. Would be right there. Draw a little arrow showing how we got there. My quadrant is quadrant 1. And my reference angle is how much farther I need to go to get to -360. And again, if you're stuck on some of these, grab a calculator, just do 360 minus 295. So if we do that, again, if you can do it in your head, that's great. If you do it on a piece of paper, that's fine too. But 360 minus 295 gets me 65 degrees. My reference angle is 65 degrees. Again, always positive, always between 0 and 90, always to the x-axis. So I come down here, my last set. Oh, wait a second, 400, that's positive. And I'm going 0, 90, 180, 270, 360. I ran out of space. I've gone all the way around. I still haven't made it to 400. Well, this is what we were just talking about. You can add and subtract 360s from this to get a coterminal angle. So if I don't want to add 360 though, that would make it too big. I want to subtract 360 here. 400 minus 360 would be 40 degrees. So 40 degrees would be here, but the way I got there would be going, let's make that a little bit closer to 40 and be like right here. I'd go all the way around the circle and then I'd keep going and end right there. Takes me all the way around and back to that line. So notice I went all the way around 360 degrees plus an extra 40. So this again, quadrant 1, reference angle is actually the 40 I just found up there. I went 40 degrees past 360. 650, same plan. I'm seeing that and I know that's going to be too big for me to fit on here. So subtract 360, 650 minus 360 gets us 290. That's going to fit a little bit better. Here's 270. Here's 360. This was equal to 290. So 290 would be right here. But again, I went a full 360 degrees around, and then I kept going until I made it there. Almost 2 complete rotations around it. And oftentimes I talk with everybody about, you've probably watched like Winter Olympics or skateboarding or anything. You've talked about 360, someone on a board flipping around all the way around, so they're facing back the same way they started. That's what's going on here. We're turning all the way around the circle, 360, ending up back where we started, and then we keep going to a full 290 degrees. So here, my quadrant, I'm in quadrant 4. 1, 2, 3, 4. And then my reference angle, that 290, I need to know how much farther do I need to go from 290 to get to 360. So 360 minus the 290 there is going to get me a reference angle of 70 degrees. You can do the same thing with negatives. This negative 480 is too big. I can add 360 to it. If I do that, I have negative 120. Negative 120, you can stick with the negatives and do negative 90 here, negative 180 here, and say, okay, we went all the way around. We're getting to negative 120, going all the way around in the negative direction and a little bit more, ending right there. Notice I always start on the positive x-axis, just like we said, that's our initial side. Again, that's up here at the top of our notes. We're starting on the positive x-axis every time. So here, going all the way around, I end up in quadrant 1, 2, 3. My reference angle is how far I need to go from negative 120 to get to negative 180. That looks like another 60 degrees. So my reference angle, 60 degrees. You could get the same thing by adding another 360. If I add another 360 to this, taking my negative 120 plus 360, and I get 240, that's going to be in the exact same spot here, but it's going to go the other way. It's showing me how would I get there going this direction. That's great if you want to work with positive numbers to get your reference angle, but remember that your actual drawing, the actual angle was negative 480. It's got to go in the negative direction all the way around and a little bit more. You can add and subtract 360 as many times as you want, but do keep track of how many and which direction so you know which way your angle is curving. And then negative 570 here, negative 570, it's too big, it's back beyond 360. So I'm going to do 360 or negative 570 plus 360. And get 210, negative 210. So again, if I'm doing it this way, this is negative 180, but I don't quite make it to negative 270. So negative 210 would be like right here, going all the way around the negative direction. Here's negative 360 plus another negative 210 to get me to a total of negative 570 right there. And our quadrant is quadrant 2. Our reference angle is we went past negative 180 by about 30 degrees. Negative 210 right here is 30 degrees past negative 180. So 30 degrees, always positive, always between 0 and 90. So we've got all that set up. That's all you're going to be asked to do on the homework. Unfortunately, like I alluded to, the homework problems are tiny. There's no room for you to write any kind of work here. If you need to show work, do it on a separate piece of paper. So a couple quick things, the way this is looking here, if I just grab one of these real fast, 100 degrees right there, I'm going to make my standard position angle. So that'd be right there because it's beyond 90. I draw it in. You must draw it in quadrant 2. And this is 100 degrees, which means I need to go another 80 degrees to get to the x-axis. If you've got ones, let's see, where's the biggest one on here? Oh, doesn't look like they throw any where you have to go around twice. But like if you take that 705, subtract 360 from it, 705 minus 360, that would give you the angle that you're looking at. Now down here, these are related to what we were doing on the section 1 homework. we're again building up towards the unit circle. So they're giving me a x coordinate, which means this distance, -3/5, is this right here. And this is 1. If that's the case, I can find this missing side here by using the Pythagorean theorem. I can do -3/5 squared plus, call it the y coordinate squared, equals 1 squared. Or if you don't like dealing with fractions, we can multiply that whole thing by the denominator. So we can take this, here's this side right here, -3/5. This is 1. I can multiply all of this by 5. And if I do that, then those two sides become -3 and +5. -3/5 times 5 is -3. 1 times 5 is 5. I can then use the Pythagorean theorem to find this missing side. So if I do that, -3 squared plus x squared equals 5 squared. If you work that out, we get 9 plus x squared equals 25. Subtract, we get x squared, right? Because the negative's inside that squared, so it becomes positive. X squared equals 16. Take the square root. I get that this is 4. Okay, except the problem is that I multiplied everything by 5. If I actually want this value, I need to divide by 5 again, shrink my triangle back down. So this ends up being 4/5. 4/5 right there. That looks like y. Let's fix that. 4/5. That is my y value. And it makes sense that it's positive because it's going up. You have to check that. If this had been going down instead, I need to switch that over to negative. Now, if you made this little triangle here, I would use this guy to find my sine, cosine, and tangent. Now, a quick note, you do need to specify where those negatives are. This is -3, this is +4. So sine would be the opposite over hypotenuse, so 4/5. Cosine would be adjacent over hypotenuse, -3/5. And tangent would be opposite over adjacent, 4/-3. There's my sine, cosine, and tangent from this one piece of information, the x coordinate there. So here, notice this is negative. That's describing the x value right here. If I find the y value, that should be negative also. You can do this using the fraction. You could set it up -12/13 squared plus the x value squared equals 1 squared. You can solve it just like that, and you'll get the correct answer for x. It'll just be a fraction. If you do that, you need to give it as a fraction, no decimals. So if you don't want to deal with the fractions, multiply everything by the denominator, in this case 13, expand that triangle so it's all whole numbers, get your answer. This one, they give us the y coordinate right here. When we find that x coordinate, it should be positive right there. All right, on the next one here, this next piece is actually a reference to the special right triangles that we were doing yesterday. So it says filling the missing sides for the special right triangles found below, then find the acute angle theta that satisfies each of these. So if this is a 30-degree triangle, fill in the sides, 1, 2, square root of 3. If this is a 45-degree triangle, 1, 1, square root of 2. If this is 60, 1, 2, square root of 3. You are expected to have those memorized, but you can write them down right now on your homework, and then you're just going to match up each of these with one of the triangles. So sine, opposite over hypotenuse. I'm looking for an opposite side of root 3. And again, you might want to just write that down. This is going to be opposite. This is going to be the hypotenuse for sine. Opposite over hypotenuse. Here, this one over here has an opposite side of the square root of 3 and a hypotenuse of 2, which means that this angle, theta, is 60 degrees. All of your answers here for 20 through 27 are going to be either 30, 45, or 60. So work your way through. There is an issue You're going to get down here to cosine theta, and this happens once or twice, 2 other times. There is no triangle with a adjacent side of root 2 and a hypotenuse of 2. That doesn't exist in those 3 options. The reason we have that problem is this has been rationalized. Remember, we're getting rid of square roots on the bottom. This was actually 1 over the square root of 2. You're essentially going to unrationalize that. Take it back to that square root on the bottom. Now I can find one that has an adjacent side of 1 and a hypotenuse of the square root of 2. That theta is 45 degrees. So again, that happens 2 other times in the homework here. Now, 28 and 29 are supposed to be review, but I find that oftentimes, especially in the last couple of years, if something got tossed out, it was probably this from the math 2. So here's my little suggestion. If this jogs your memory, great. We'll come back to it if not. This one has a 13 and 13. These are 2 sides that are exactly the same, which means this is a isosceles triangle. And again, I can then drop a height of the triangle that cuts this straight in half, puts this at 12. You can now use what we've learned in the past to find this angle or this angle. Well, actually, they want you to find sine, cosine, and tangent. So sine, cosine, and tangent of A, all you're missing then, you've got an adjacent side and hypotenuse. You just need to find the height of this triangle using the Pythagorean theorem. Essentially, they're just giving you some extra information here that you can kind of use and ignore to some extent to find the missing pieces, just like we did yesterday. This one's telling you, okay, tangent of B is 24 over 7. So tangent is opposite. So 24 at the opposite side over adjacent 7. Use the Pythagorean theorem to find that missing hypotenuse. And then you can find sine, cosine, and tangent of A. Notice that now, for these down here, they told us one of B. Now we're doing of A from there. So again, that's hopefully review. If not, work it out. Again, use the people at your table, ask each other questions, check your work with each other. If you're all stuck, see if you can check with another group that maybe someone has figured out what's going on there. There we go, though. That's the end of section 2.